Welcome back. I promise you that in our next video, I'm going to show you a very simple method of expanding higher powers without going through any form of stress. So here we are. Let's go there. So recall in my previous video, I said if you have x plus y raised to power 0, that the answer is 1. X plus y raised to power 1 is still x plus y. X plus y raised to power 2 is x squared plus 2xy plus y squared. And then we said that x plus y raised to power 3 was x raised to power 3 plus 3x squared y plus 3xy squared plus y cubed. This is where we stopped in our previous video, so to say. Now, I want you to observe something. Like I said, a mathematician had to look at it carefully and came up with a pattern that instead of doing this, we can actually go the easy way to get higher powers expanded. And what did he do? He came up with a triangle, and that triangle was named after him. And that triangle is called Pascal's triangle, which means that the research was carried out by Blaise Pascal, a mathematician. So what did he say? He observed that anything raised to power 0 is 1, so we have 1. Then if you expand x plus y raised to power 1, what you get is x plus y. Now, if I may ask, what is the coefficient of x? It is 1. What's the coefficient of y? It is 1. In power 3, the coefficient of the first term here is 1. The last term here, the coefficient is 1. So he came up with a pattern that the first one is 1, which is this. The second one, power 1, is 1 and 1. So we have something like this, 1 and 1. Then, to generate the third one, this is what he did. He added these two numbers, these two 1 here. So he said 1 plus 1 will give us 2. So he wrote down the 2. And then at the extreme ends, he dropped 1 here and dropped 1 here. And then, remember, this was when you were expanding power 0. Power 0 was what gave us 1. Then power 1 was what gave us 1 and 1. Power 2 gave us 1, 2, and 1. This is 1, 2, and 1. So this is for power 2. Then to expand power 3, what did he do? He added, in between this 1 and 2, you add 1 plus 2 is 3. You write down 3. 2 plus 1 is 3. You write down 3. At the extreme end, you put 1 here and put 1 here. So you can see the pattern that for power 3, look at this is power 3. It is 1, 3, 3, 1. 1, 3, 3, 1, which is the coefficient. Which means that if I am to expand x plus y raised to power 4, what I'm after is the coefficient now. So the coefficient, if I expand power 4, what will be my coefficient? What did he do? 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then at the extreme end, you drop 1 and drop 1. So Pascal now came up with a triangle, which is called Pascal's triangle, as 1, 1, 1, 1, 1 plus 1, 2, 1, 1, 1 plus 2, 3, 2 plus 1, 3, 1, 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1, 1. This is for power 0, power 1, power 2, power 3, power 4. Meaning that if I am to expand power 5, what I'm interested in is the coefficients, just like we have the coefficient of 3 to be 1, 3, 3, 1. So if I'm expanding power 5, what should be my coefficients? It's very simple. Just do the same thing. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Then 1, 1. I probably will write this better, but he formed this triangle. And this triangle helps us a lot when we are carrying out binomial expansions. Okay, how then do we apply this in expansion? Let's look at it quickly. Let me start with power 2 to make it clear. I have x plus y raised to power 2. I want to expand this. So I have x plus y raised to power 2. If you notice something, there's a pattern there you have to notice. First of all, ignore the coefficient. We are not interested in the coefficient. We are interested in the two numbers inside the bracket. So the first step is carry these 2, drop on top x. So you have x raised to power 2 plus. Immediately after that, in the subsequent terms, you will notice that the power of x, immediately you get the first x, the next x will reduce, whereas the second number will increase. So as the first one it decreases, the second one increases. Okay? So look at it. There are two terms here. So the first one is x raised to power 2, meaning that the second one will be y raised to power 0. It's not there because y raised to power 0 is 1. So it doesn't have any effect. Plus, then this x will now reduce to power 1 and y will increase to power 1. At this point it is 0. Next it will now be y raised to power 1. Plus, this time around it will decrease from 1 to 0. So you have x raised to power 0 and then y raised to power. Y will now increase from 1 to 2. So that this will give us x squared. Y raised to power 0 is 1, so it's gone. Plus x times y. Y raised to power 1 is the same thing as y. So you have xy. Plus x raised to power 0 is 1. 1 times y squared is y squared. So you see that as the power of x decreases from 2, 1, here it is 0. The power of y increases from 0, 1, and 2. Then after that, you ask yourself, what power was I working with? You will see that you were working with power 2. Then now go to Pascal's triangle to find out power 2. What is the coefficient for power 2? The coefficient for power 2 is 1, 2, 1. So you come here and drop 1, 2, 1. Of course, there is no need of putting the 1. So it's just x squared plus 2xy plus y squared.